So here we will begin. This is very interesting to go with. I'm going to talk about linear regressions, and I'm going to train my model. So before going to that part, just look upon the basics about what the linear is really all about. When we talk about linear equation, it holds a very simple relations in which uh, we have something called as a slope, we have something called as intercept. Let's talk about this example, which is been depicted here. We can see that slope of this line is 2 and the intercept is 3. And the equation becomes y is equal to 2 mx plus b. So it equals. In that sense, if I would say that y for this line is 2x plus 3. So we can see that I vary my x, by even 1 units. There is there is uh, the increment in y by 2 times. Two units. So as x varies, uh, my y also varies m times. As simple as that. So it's not that m is going to be positive; it's going to be even a negative value as well. So slope, which is as easy as that. So if this line holds an angle theta with the x-axis, the tan of that angle becomes my slope, and the intercept is the value of the intersection of the line at the point of y-axis. You know, that means when my x is 0. So we have nothing more to look upon all this, but the thing is that it's an easier uh, interpretation of the linear equation of line, in which we have two variables. One is the x variable here, we can see, which is the independent variable. That means it can hold any values ranging from minus infinite to infinite. So it's like whole range it have to look upon. But when it comes to y, it depends on x. That's why it's independent. That's why it's dependent variable. So we see that this relation, which is y is equal to mx plus c, is a linear equation. So now we're going to look upon something like we have got the different, data sets, and I want to plot the line for that. So it's like many times you have seen that it's not so perfect, but it it converges to perfection. So when it comes to data as this one, where I want to have a relation of this data points, uh, in terms of y and x, then something very familiar, linear relations could be hold, though it's not a perfect. Like, how can I have something as this line? So better if I have some relation which holds, uh, you know in terms of fitting the curve. It's just a very befitting words over here. So uh, what is, you know a linear regression is going to do this. So what we opt for this, that let's say I plot some line and going to look upon the uh, values of y, you know this amplitudes of this different points with the lines, and I'm going to square them up. Yeah, square them up and add all of them. And for when we could talk about least square, so the sum should come up the lowest. So the line which holds the lowest sum is going to give me the linear equation. So that's how we go for interpolation of the line with the given data. So what I'm going to look at this, because this is the time we are living in, which we depend on the machines. So we're not going to do this by our own selves. The machines do for us. Even we need not to specify how they are going to do, because machine know how this whole function works. So we have something called as Python program.